Okay, now we're talking about work done by fluids. So let's pick that up. First of all, we need to just understand there are two different types of systems that we're going to deal with in a fluid world. There's an open system and a closed system. Now, this may be a Captain Obvious type things. An open system is which I can add or remove fluids. So something like the water system in your house, your air conditioning in which you're adding air and taking air away, it's open. It's not a closed system. A closed system, we just simply reuse or recycle the fluid over and over again. This would be like your car brakes. Hydraulic jacks are also closed system because I don't add fluid to those on a regular basis. Your transmission, your power steering, your power brakes, all of those would be examples of something that would be a closed system, and we don't add them. Now, our general equation for work. Remember, we've talked about force in all the areas. Now we're going to talk about work in all the areas. Well, work is going to be the force like quantity times a displacement. In other words, in our definition, something has to be displaced. Well, for mechanical work, work was equal to F times D, force times displacement. In fluid work, work is going to equal, well, the force like quantity. The reason things happen in a fluid system is because of pressure or change in pressure, and the displacement like quantity is going to be volume. So we usually use capital P for pressure and capital V for volume. Now, key thing to understand is there's two separate things that can happen. I can change the pressure while keeping the volume the same, or I can keep the pressure the same and change the volume of the fluid. And we'll do a lab that actually involves each one of those, so we can do it. Now, let's quickly play with this equation real quick. Work is equal to force times distance, and this equation, and I'm going to show you actually they're the same equation. If you think about pressure is equal to force over area. Okay, we know that from earlier. Well, volume is nothing more than area times height. But instead of height, I'm going to write distance. So if I have something like a circle, volume would simply be the area of this end, pi r squared, times that d. If you think about it with a rectangle, well, that would be length times width. That would be d. Length times width times d gives you volume. So in all cases, that actually works. Now watch one thing. Watch what I can do with it. If I take this equation and I'm going to say work, and I'm going to go with a P delta V equation, well, pressure is force over area. If I multiply that times the volume, which is area times d, areas cancel out. The units are the same as they were before. In the SI system, it's going to be newtons times meters. In the English system, it's going to be foot times pounds. So the units aren't any different than they were before. Okay, let's look at an example problem. This is a type of example problem you could have to do. A hydraulic piston moves 20 centimeters when it's pushing something, and the pressure on it is 10,000 newtons per centimeter squared. The area of the piston is 2 centimeters squared. How much work is done? Well, we know we're talking about work. We know we've got pressure, so we know that we're going to say work is equal to pressure times volume. Now, one of those is going to change. So we'll take a look at that. The pressure in this case is easy, 10,000 newtons per centimeter. When you write units, I'd write them like that. It makes it easier to work with. Now, volume. Well, volume is nothing more than area times d. And in this one, they actually gave you the area. Now, they could give you the radius of the piston. And that's what we'll do in a laboratory setup. So now I simply go 10,000 newtons per centimeter squared times, well, the area is 2 centimeters squared, times the distance it moved, which was 20 centimeters. So I'm going to have 10,000 times 2 times 20. That's going to be 400,000. You got a calculator, you can check me if you want. Now take a look at the units. I have centimeters squared on the bottom, so that cancels with that. So I have newtons times centimeters. Now if I wanted to convert that to newton meters, just as a nice review, we would simply take and multiply this. Centimeters on the bottom, I want meters on the top. 1 meter is 100 centimeters. So therefore I would have, chop 2 zeros off that, I'd have 4,000 newton meters of work. So that's the type of sample practice problem we can do. Now remember, you may have to be careful. They may mix centimeters and meters. You need to be able to handle that. We'll practice it. If you can't, you'll have to do it in the lab setup. Remember, fluids can do work whenever I force them to move, and it's the pressure transmitted through the fluid that allows it to do. It's how your brakes work in your car. It's how your home water system works to deliver water to your house. So indoor plumbing is a good thing. Back in the Stone Age, when we had to go outside and use nature's urinals and stuff like that, life was not as good as it is now. Indoor plumbing is a wonderful thing. We'll do more in class.